I think. Is it? Yes. Looks like we're live. Hey, welcome everybody once again to Astronomy Discourse live. Hope everybody's doing well. It is 22 hours UTC. Gotta get used to saying 22 instead of 2 hours. 22 hours UTC on the 4th of September 2019. So yeah, hope everybody's doing well. Got the music playing again in the background, so let me know if that's okay. Yesterday I was watching and listening later, and it seemed a little bit loud. So I've turned it down a little bit. We'll see how that goes today. But yeah, so hope everybody's doing well. Welcome everybody. Here is a live stream almost daily, where we sit back, grab our consumables of choice. In this case, this is hydrogen hydroxide. Can you see that? You can see a little bit of it. Hydrogen hydroxide, HOH. It's a very, very calming molecule, pervasive throughout the universe, and very, very amazing. A very, very amazing molecule in a very amazing universe. And yeah, so everything's good here. Just sort of a normal day. Just yeah, doing really, really well. So yeah. So the Indian Space Agency is just a couple of days away now from attempting to land on the moon. Their lander. We can actually let's pull that up here really quick, because I was just looking at it, and of course I was looking at it, and then I moved away from that and went somewhere else, and of course I'm not finding it now, but I think we can find it again. Oh, you know, I made a link to it over on my Discord server, which you'll find a link to down below in the description. There's a little invitation there, and you can go and participate in that. It isn't the most active Discord server there is, but yeah, it's not too bad anyway. So yeah, let's I definitely want to pull up and show you what's going on with that spacecraft. They're about to land, and here we'll just do this, and then I'll share my screen like this. Oh, drop the pen on the floor. So here's sort of their updates website here, and scooch down and see that September 4th they have a little update for today. So they did a second deorbit maneuver, they call it, and that happened well, a while ago now, about 20 hours ago or so. And so the lander right now is on a 35 by 101 kilometer orbit. So that's just getting scary close. So, and I guess what they're saying is that the lander is scheduled to do a powered descent between 1 and 2 hours IST. I guess that's Indian Standard Time. I don't know how that translates to UTC. That's a little annoying that they would do that. But of course, they're a few hours ahead of UTC, so I don't know how much. It's got to be 4, 5, 6 hours ahead. So, but anyway, that is happening sometime on the 6th or 7th, and then the landing is supposed to happen soon after, right, between 1:30 and 2:30 IST, which looks like to me that's probably at least where I am over here. Well, let's see if IST is I guess we could find out. IST time zone. Okay, so, oh man, they even make it more complicated. IST is UTC plus 5.5 hours. Okay, so what that means, let's just take it at 2:30 hours IST. Okay, so to get to UTC, you got to subtract 5.5 hours from that. So that puts you at 21 hours UTC, right? So 2:30 IST is going to be 21 hours UTC, and at least where I am here in southern Arizona in the United States, I'm 7 hours behind UTC. So 21 hours minus 7 is 14 hours. So 2 p.m. in the afternoon on the 6th. It sort of looks like by not tomorrow afternoon, but the afternoon after that, the 6th, here in North America, they will have landed. They will have landed. So, yeah, just a couple days away, 47-ish hours or so. So pretty exciting. Pretty exciting. Now, as you recall, the Israelis made an attempt at a landing a few months ago and failed. They I forget exactly what the cause of that was. I'm kind of confused as to why there's nobody in the chat. Why is there nobody in the chat? I'm gonna quickly I'm gonna switch you back over here so there isn't any incriminating evidence. But I need to maybe see. It sort of looks like everything's live. Oh. Looks like everything's okay. Oh, need to go over there. Yeah, that looks good. Okay. Alright. Ah, the music is too high. Music is way too high. Let's bring that down a little bit. Okay, sorry about that. Niji, hey, nice to see you in the chat. Hope all is well. I just turned the music down a little bit because to me it sounded a little bit loud. So we'll see what it looks like now. Oh, maybe not. I need to, wow. I don't know how to do that. Okay, you know what? I'm going to leave it at the same level, and somebody can tell me. Somebody can tell me if it's loud or not. Whoever is listening out there. So Okay, well, cool. So yeah, that's happening pretty soon, and it's a pretty exciting thing. You know, not too many countries or entities have you know, had the opportunity or actually landed on the moon. As far as I know, there's only 3 that have accomplished that. So the Israelis tried and failed. So now the Indians are up there, and they're getting within 35 kilometers of the surface of the moon right now, with a landing that's going to be happening in just a couple days. So cheers to them. I hope all goes well. So cheers. All right, cool. So the storms have knocked out some people's power. Maybe, I don't know. You know, I've got a worldwide audience here, so don't know. I think did I end up tweeting that out, or did I? No, I did. I tweeted it out. I put it out on the Discord channel, so we're good there. So I think we're okay there. So, all right. The storms have knocked out some people's power. Yeah, I think hopefully you won't be hearing the audio repeating now. I had to turn up my speaker in order to hear things, but yeah, I hope it's okay now. Oh, you know what? It's not going to be okay now because this is probably playing through that. So okay, now I'm going to mute that. And yeah, all these weird things, but yeah, the sound. Okay, yeah, I think I've got that cleared up. I just wanted to make sure that I was actually running live here, but it looks like I am. So yeah, I think I'm all right. I think I'm good. All right, cool. I'm gonna grab my chat here. All right, well, cool. Well, where we were last week was we had started doing a object of the day, and that object was NGC 5576. This very large, very bright elliptical galaxy over in the constellation of Virgo, and got through a little bit of it. I think we calculated it was something like 78 or 80 million light years away. We looked at a couple of images of it with the HST. Looked at a couple of spectra too. So yeah, it looks like it's part of the Virgo cluster. That wouldn't be too surprising. It's a nice elliptical. Looks like it's got some companions, etc., etc., etc. There seemed to be, when we went over to Simbad, there seemed to be a lot of references, a lot of scientific papers that supposedly mention this object. So I think that's sort of what I want to do today. Is just go through some of those papers, and I mean, not that this is necessarily going to happen, but one thing that would be nice would be to sort of understand why this object has been studied so much. There were almost like 300 papers, if I remember right. So yeah, let's go over there and find out. I think I've got Simbad pulled up here. I do. Yeah, I just had my YouTube running at the same time. So as soon as that's gone, shouldn't be any more echoing or anything like that. So, okay, I've got Sinbad up and running, so I'm going to share my screen again here. Bam. Like that, and then I'll come over here and we will do NGC 5576. We already went through a lot of this, so I'm just going to go right down to the references here. Yeah, 291 references. So that's a lot. That's a lot. You know, it's that means that something is up with this guy. Whew. All right, here we go. This is just supposed to be a nice, relaxed. Oh, we have a doorbell there. That means we have a delivery of some sort. I'm here at my day job, so it's always going to be a little bit of activity, but no real worries. All right, so Sinbad is nice enough to order these papers by date, so we can actually look at these. These are the latest ones, and then it goes back in time. So maybe we'll scan a few of these more recent ones, and then maybe go back to the first one and see. But yeah, already I'm seeing dust, Dustpedia, right? Multi-wavelength photometry of 875 nearby galaxies in 42 ultraviolet to microwave bands. Holy moly, that's a lot of work. I wonder if they're pulling that information themselves, collecting that information themselves, or if they're grabbing it from other surveys. That's pretty impressive. Maybe we should look at that, because it's some photometric stuff and some images, so that's always fun to see. It looks like it's in the journal Astronomy and Astrophysics just recently. So yeah, let's go to the ADS entry here and grab the paper. We can do it off of archive. I'm already seeing a pretty interesting plot there. Looks like a pretty big paper. I'm not surprised at that. It's insane how long some of these papers are. What is this one? 31 pages long. It's got a bunch of authors. Looks like, let me zoom in here a little bit. So, UK, Belgium, Italy, Mexico, Greece, France, Germany, Russia. So, yeah, European for the most part. Cool. Dustpedia, multi-wavelength photometry and imagery of 875 nearby galaxies. So supposedly, hopefully, we will find NGC 5576 in here too. What you got?
Might we have some AA batteries back here?
Double A's?
Sorry.
All right. As I said, being at the day job here, there's going to be a couple interruptions. No worries. We are easy here. We are easy. We're casual. No sweat. No sweat at all. Okay, so I'm going to go back to the paper here, and let's just look for 5576 to begin with. See if it's here. Well, I'm not seeing it designated that way, so all right. Well, let's sort of go through this, I guess, and see what we've got. It's working towards a definitive understanding of dust in the local universe, capitalizing on the Herschel telescope. Herschel, man, I know that Herschel was a space telescope, but dang, I don't remember what wavelengths it was looking in. So well, we might be able to find out. But here's a, oh wow, so here is the Dustpedia archive. Ooh, we should go over there and take a look, huh? Yeah, we should. We really, really should. But let's get through this first. There's so many distractions. There's always lots of distractions when it comes to astronomical stuff. And that's part of the fun thing with this live stream is that, you know, I am just following my nose, following, you know, curiosity, and I'm taking you along with me. So that's what it's all about. So you know, there's nothing planned here or scripted or anything else. But let's go down here a little bit, see if we can find some pictures. Looks like there's one loading. Okay, so this is the spectral coverage provided by the Dustpedia database. So what these basically are just transmission percentages. So these are sort of like filters. You can imagine them as being like filters, and everything that you see that is colored here is a wavelength band that has been observed, and this is in units of microns. So 10 to the 0 here is 1 micron, so that's 10,000 angstroms. This is 0.1 microns, or that'd be 1,000 angstroms. So this region here is sort of, you know, the visible region, and then everything else out here is you know, this is 1 micron, so that's you know, already pretty far towards the infrared. Here's 10 micron, 100 micron, 1,000 micron. So 1,000 microns is 1 millimeter, right? So this is millimeter wavelengths. This is 10 millimeter wavelengths. So yeah, they've gone pretty much from about well, maybe this is on a logarithmic scale. So 0, 1, 2, 3, 4, 5. So yeah, you know, I mean, more or less 1,000 angstroms up to about, what did I say? 10 millimeters. I think that's about right. So, and there's a few gaps in here where, you know, we don't have any kind of data at all, but pretty good. I think for the most part, except the ultraviolet down here, a lot of this can be observed from the ground. Maybe not this complete, but you can also see here, you know, that some of the surveys actually overlap others. So and they're all labeled here too. Galex. Galex is out here. Spire, yeah, pretty good. That's that is pretty amazing in terms of wavelength coverage. Pretty good. Pretty good. Herschel imagery. Here's some images of some sort. Okay, yeah, there's some kind of weird background patterning here. Okay, here are all the details. So here's the wavelengths, and yeah, you can see it goes all the way out to 10.6 millimeters there, and all the way down to 153 nanometers. So the difference between a nanometer and an angstrom is just a factor of 10. So to convert nanometers to angstroms, you just multiply everything by 10. So you can see that the Sloan Digital Sky Survey was mostly, well, it was all in the visible. Yeah, so pretty complete. Oh, sorry about that. This is a nice, relaxed live stream today, apparently. Let's see who else is in the chat. Uncle Bill, nice to see you in the chat. I'd have a case, each double A's, triple A's at all times. Yeah, yeah. Well, we are always either losing things here or running out of things here. So, okay, yeah. So Herschel was a far infrared and submillimeter. So spreadsheets. Uncle Bill is buried in spreadsheets. All right, let's keep going here. Sloan Digital Sky Survey. I want to see this Dustpedia. That's what I'm kind of curious about now. But I'd like to find our object in this too. So yeah, here they're just talking about how they process the data. They've got their pipeline photometry processes now, where the data, it comes in, and then at the end you get all these data products. Some of them are photometry, some of them are statistics on the background sky, maybe cosmic ray detections, just on and on and on. There's a lot of possible data products. So but okay, yeah, here they're showing how they subtract a sky from this very, very complicated thing where you really don't have a a good means of measuring the background sky, because you got all this dust and stuff everywhere. So they give it a try. Oh man, it's awful. And I guess they have convinced themselves that this is working. So very cool. Here's some more stuff. Aperture fitting. Yeah, to do photometry of anything, it's like, okay, well, let's just take the this first thing. So this is sort of your input, and say that you want to measure the brightness of this galaxy. Okay, well, what is the brightness of the galaxy? Is it the brightness in here? Is it the brightness here? Is it the brightness here? Is it the brightness of all the galaxy? Well, if it's all the galaxy, how do you define that, right? And I mean, we're pretty good at doing this, right? I can just sort of do this really, really roughly and make probably a pretty decent outline. See, now over here it gets a little funky, right? It's like, you know, I don't really see a well-defined edge there. So and it's like, well, okay, maybe this way, right? So that's sort of what they're showing here is, you know, the process that they went through to sort of figure out what, you know, are these pixels here part of the galaxy, and do we want to measure those brightnesses? And then, you know, to measure the overall brightness of the galaxy, you basically just add up all the numbers. That's it. Now there's a lot more that they're doing here too. They're doing, it looks like, probably sky subtraction and you know, all kinds of other things. Even getting into morphology a little bit, right? These aren't round round apertures. They're elliptical. So yeah, that's pretty neat. Yeah, here's more of the same on NGC 4559. That's actually a nice galaxy. I've looked at that one. You can definitely see 4559 in a moderately sized scope. Okay, so here they're doing some kind of noise measurements, and yeah, it's just crazy what you have to go through. It's all part of the scientific process. Being able to make good measurements that are both accurate and precise. Two tough things. So all right, we're getting through here. Plot showing how uncertain. Okay, yeah. So they're, you know, they want to be confident that their uncertainty is sort of as small as possible, and sometimes it is, and sometimes it isn't. Checking through here. Okay. Definitely not seeing our target object here. So it's probably not going to be listed in any kind of table or anything. But my guess is that if we go back up to the Dustpedia, the Dustpedia website, and let's just see. You know, I've never been here. I have absolutely no idea. Let's just dive in. So here, there's a link that's called data. That's always promising. Okay, here we can type in our galaxy name. Let's see if NGC 5576 comes up. We'll just leave everything else alone. We'll just take all the defaults. Well, I'm not seeing that. I'm sort of wondering if it's going by a different name. You know, as you know, these objects have many different names. Well, let's try the UGC number, 9183. UGC 9183. Well, I don't know. Let's look at photometry then. Dustpedia main photometry. I guess let's do that. Uh-oh, it's gonna download this huge file. That's not what I wanted to do. Archive contains photometry across 42 UV to microwave bands, blah, 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 blah. The user can retrieve the derived photometry tables from the links below. Provides all the available photometric measurements. Okay, well, it pulled up a CSV file here. Why don't I think I can pull that up and then share it, because I don't think that you're going to be able to see it right away. But I can make a little view here. I'm going to take a quick look at it. So you guys, yeah, you guys are still just looking at that. So, yeah, I guess that looks right. The formatting. Okay. This is pretty big, it looks like. Okay, you're not able to see that yet. Let me see if I can add another window here. And let's see, where is it? There it is. There. Okay, so I'm going to switch you over. Oh, so I think you can see that now, right? I think you can. Should be able to. Methinks. I'm going to confirm that one way or another. Yeah, it looks like it. Hey there, Mustafa. How are you today? Hope everything's well. Yeah, so it looks like that is working. So yeah, again, it's going to be a thing where, man, we're going to have to go through this whole thing. 5576. Well, let's go to the next one. Just a bunch of numbers. Let's do NGC 5576. NGC. There it is. There, we found it. I don't know what these columns are. Right ascension, declination, semi-major axis in arc seconds, axial ratio, position angle, and then a bunch of fluxes, right, which is just brightnesses. So, okay, well, wow, that's a lot of data. But it looks like the first 1, 2, 3, 4, 5 columns here, B through F, are probably the moderately most interesting right now. So this is just the right ascension and declination in degrees. So in order to convert that to hours, minutes, and seconds, and degrees, minutes, and seconds for finding it in the sky, you'd have to do some conversions. No big deal, no big deal. But yeah, there is the right ascension and declination, and then what did they have next? Semi-major axis, axial ratio. So semi-major axis is 306.6 arc seconds. So that's pretty big. That's a big galaxy. That's about 5 arc minutes all the way across. And that's pretty large. The moon is only about 30 arc minutes. So this is about 1/6 of the size of the full moon. So yeah, it's relatively speaking, that's pretty big, pretty darn big. So the ratio between how long it is and how short it is this 1.538. So it's about 1.5 times wider than it is narrow. That's pretty cool. We could actually plot all of those here. That might be an interesting plot. So okay, well, cool. That's probably enough of that. We found our target, so that's good enough. It's good enough for now. So okay, I'm gonna switch you back to that whilst I get rid of that big huge table. And yeah, I guess being the stubborn person that I am, I would still like to see if we can search in some way. So I'm going to go back to Dustpedia, and let's go from there. So okay, that's gone. I'm going to get rid of that actually. Goodbye. Because maybe it's all we have to do is just make this one word, NGC 5576, like that. Sometimes you have to be a little determined. Aha! There it is. Okay. So I'm going to zoom out a little bit. So this is just all, yeah, just as they said, this is just the data. I don't have a fits image viewer here. So it's not going to do us very much good. Oh, there are some photometry cutouts. I'm not quite sure what that is. Oh, it's an image of some sort. A very big image. It's a PNG file, but it's big. It's like almost 8 megabytes in size. So I don't know. I don't know what to expect here, but that's what makes this live stream fun. Is that who knows? Who knows what's in store here? We're gonna find out. So it's calling it a thumbnail grid. A thumbnail grid. And let's see, is it done? Looks like it's done. I'm gonna try to open it. How should I open it? Just with the regular image viewer? Maybe I'll open it with GNU, with GIMP. Let's try that. So I think I actually have a GIMP viewer on here. It's always fun to follow your nose a little bit. This is a big file though. This is like 8 megs, 7.5 megs or so in size. So while we're doing that, cheers. I'm gonna stop slouching a little bit. Cheers. Actually, I need to put this over here because otherwise I'm gonna knock it down. Okay, so I think I can I go over to GIMP? Yeah, okay. So here it is. This is, well, this is definitely NGC 5576. I remember from seeing it before. And yeah, I think what this is showing is just, the different instruments, Galex, SDSS, different filters, two mass. So this is pretty cool because we're seeing this galaxy at many different wavelengths. What is that? 7 times 4. So like 27 different wavelengths here. And I think that's all there is. Now, when you're getting down here to, what is this thing? Pax. I don't know exactly what Pax is, but yeah, I don't think there's anything there. Pax, for one reason or another, isn't really seeing anything. Right? Spire, it's so hard to tell. I wonder, are they using the same? It looks like, and I mean, this would sort of make sense. They've put this galaxy on the same scale in each image, and then they've done your photometry on it in exactly the same way. So the shapes and sizes of these green rings are all exactly the same. So regardless of what wavelength or spatial resolution they are working with, they're doing photometry on the same piece of sky. And as you can see, I mean, generally speaking, they all look the same, right? Here's our main galaxy here, and then it's got that little companion over here, and we sort of see that in all of these. But look at the background between Y's 3.4 and Y's 4.6. This is probably the wavelength in microns. It's my guess. So 3.4 microns versus 4.6, and look at the difference in background. So this has sort of a darker side, and then it goes bright. This looks pretty uniform. So, and I assume that all these images have been calibrated and sky subtracted and everything. So whatever this is, this stuff, it's low level, but it's there. And what is it? I don't know. I mean, it's obviously contributing to the photometry as well. So, but pretty cool. Spitzer 70, yeah, not much there. I don't know if that's is that, I don't think that's 70 micron. I don't think so. I'm not sure. But you can see how it looks different depending on what wavelength you're looking at. Slightly different, right? As I said, the general thing is there. We've got the big guy and the little guy here, and that's pretty consistent. But the background is changing. How much of these galaxies you can actually see is changing. That's pretty cool. Pretty nice. And again, this is a survey that is looking at dust. It's so the fact that we're seeing a lot of differences in terms of background, supposedly dust. Yeah, it's kind of cool. I don't know why this image is so large. I mean, an 8 megabyte image, it's only what, 3000 by 2000. So yeah, I'm not quite sure what's going on there, but yeah, pretty nice. All right, well, let me close that. We'll go back to here for the moment. I'll close up GIMP. That's a pretty cool resource there. Maybe I'll before we get totally off of this, let me see if I can put that link over on like the Discord server here. Copy. I'm going to go over to Discord and I'm going to paste it over onto the Discord server just like that. All right, excellent, excellent. Okay, so let's keep going here with Sinbad because you know, there's a lot of things to still go through. Let's go back to the first paper. I like to go all the way back, and I'm going to change my view again here. There we go. So let's go all the way back to the first paper that supposedly mentions this object. Not too surprising, Edwin Hubble, 1926, Astrophysical Journal, paper titled Extragalactic Nebulae. So it's probably in there. Should we see if we can take a look? 400 extragalactic nebulae. Looks like we do have the paper here. Slowly loading. 52 pages. That's because, you know, at this time, back in 1926, that's, you know, you realize that's almost 100 years ago. They published everything. So we're going to have all the pictures in here, all of it. And we've seen Hubble's papers before. So, you know, the format is pretty much the same. He goes through the different nebula types and shows some photos of them. Let's see if we can find 5576. You can see some of the nice images here. These are photographic images. I think these were taken with the 60-inch telescope, either the 60-inch or the 100-inch. I think that's all they had back then. I shouldn't laugh at them, but that's all they had. There's some spectra. See if we can get down to the. Now, can we actually search? Ooh, we can. So 5576. Gonna find it. Well, for some reason it's not turning up here. Looks like it's going in sort of numerical order. Well, no, it stopped at 40. Oh, no, here it is. 5. I don't see a 5576 there. I think he's listing these by galaxy type, though. See, yeah, so these are spirals. So no, we're definitely not doing spirals. Did he do spirals first and then ellipticals? Maybe. We're going to find out. Making these amazing plots in 1926. Looks like we're getting down pretty deep into it here. Not seeing. I'm going to zoom in a little bit here for you. Sorry. Actually, that's a little bit harder to read. Let's see here. Come on. I want to see our galaxy. Masses. Wow, he's trying to measure masses. Pretty amazing, amazing, amazing astronomer was Mr. Hubble. The finite universe of general relativity. Relativity was a brand new thing back then. So, I didn't see 5576 anywhere. Look in these lists again. The lists didn't even look very big. So I thought he was talking about like 400 objects here, and I don't know if I'm seeing even that listing. It didn't look like 400 to me. E0. So I don't know what kind of elliptical it is, but if it's anywhere, it's got to be on this list somewhere. Ah, there it is. Cool. So he's calling it an E4. So that's pretty elliptical. I think the 4 has to do with you know how oval shaped it is. And yeah, there it is, NGC 5576. This is probably a magnitude. Yeah, and log D. That's probably some kind of, I don't know, maybe distance modulus. I'm not quite sure what the log D is, but yeah, it looks like he measured it at magnitude 12.3. Okay, pretty cool. So yeah, this is the first recorded observation of NGC 5576. Pretty cool. Pretty cool. Okay. Well, you know what? There's a lot left in here, and I'm noticing that we're sort of running up against the hour. So maybe what I'll do is oh, cool. Thanks, Uncle Bill. That is nice. Nice of you to do that. Excellent. Uncle Bill is always on top of things. It's impossible to keep up with him. So I really appreciate you being on my side. So no, I do not ignore chat. At least I try not to. But I get buried in these papers, and it's just you know, that's how it goes. So. Okay, well, you know what? I think for today I am going to get on out of here. We're going to continue looking at this object at least, I think, one more day. I want to get through a few more of those papers, and then we'll move on to something else. There's always more, always. So, all right, everybody. If you haven't already, make sure to subscribe. Smash the thumbs up if you so desire. Share this around. Tell a friend. As I say, you know, this is just a fun, casual get-together. We sit here amongst friends and just sort of leisurely think and talk all things astronomy. And yeah, there is so much to talk about. It's unbelievable. And so I just like to go through it and share it with all of you as often as I can. It's not every day anymore, but it's pretty close. Several times a week. So that's not too bad. So okay, everybody, I'm gonna get out of here for now. Peace, cheers, and all that. I will see you tomorrow for sure. I don't think I've got anything that would interfere with that, as far as I can tell. It's actually going to be clear here tonight, so I'm thinking about doing some kind of observing thing. I guess, you know, I have to decide exactly what I want to do and all of that. So yeah, we'll see how that goes. We'll see. Yeah, we'll see if I'm up to it or not. But for now, I'm gonna get out of here. So peace, cheers, and all that. I will see you in one Earth spin, 23 hours from now. I'll be back here at 22 hours UTC. So I'll see you then. Okay, everybody. Take care. Bye.